Well, good afternoon. This is the lecture for September 11th for MET396 Professional Seminar. I had hoped to be with you today, but as it turned out, I have to travel again, so I will not be here, and thus the video package. So hopefully next Friday, I will be here with you. But for today, September 11th, you get the video recording. And I hope you will find it somewhat illuminating on the topic of safety in the workplace. As noted on the slide, this is a disclaimer. This is not a comprehensive coverage of this topic. There are many aspects of safety, some of which are very unique to the workplace. And so this is just kind of a summary in some ways of different areas. But it also hopefully will give you some sense of some things that are related to not just workplace, but also design and your potential role within safety and design, or design of a manufacturing process, or potentially the design of a specific machine. So this, again, lecture is relatively limited. A summary of what we're going to cover is going to be some things about personal safety, because certainly that's an important topic within the area of safety, even in the workplace, particularly as a professional, an engineer, or a production supervisor, or wherever you may end up. And a little bit about some generic factory safety guidelines, the sort of thing you would expect to find in the workplace. Some OSHA, because OSHA is usually synonymous with the idea of safety, sometimes from a negative viewpoint, but should be looked at as a positive thing. And then safety and design, as I mentioned earlier, because some of you will be designing or working within process industries, where some aspects of safety have to start at the front or will be addressed after processes are running as you develop emergency procedures. The homework for this week's material will be in a separate document. It is not in this PowerPoint, and it will be posted up on the Blackboard site as well. So it's important to remember that safety is no joke. And although there are a number of perhaps humorous pictures that you can find that show unsafe situations, keep in mind all of these are real. These are not faked photographs. There are things found in different places, particularly different parts of the world. So if some of you start to travel around in a global company and see workplaces outside of the United States, you will see a variety of situations which we would not tolerate here in the United States. Some of these you might even find here in the United States, hopefully not. But again, think that you do not want to do these things for some obvious reasons. I've always wondered if this picture of the skill saw using somebody's back as the table on which to saw is a little bit of a joke, or if it was staged, but I've seen people using skill saws with having somebody's foot act as the clamp, and the foot didn't even have a shoe on it. I've seen those things myself, so I'm not too sure that this thing isn't staged. This one is, I don't think any of you probably work in high voltage power systems, but this picture of the person working up on a pole is certainly not something that would be tolerated in the United States. So bottom line, personal safety, it is your responsibility. I talked to somebody this week who works in industry and asked what they thought I would be important for me to cover in terms of a safety lecture. And they said, well, make sure you tell them it's a personal responsibility. So that's number one. It is your responsibility to ensure your personal safety. No one else will do it with the same care as you will, so make sure you pay attention to your own safety. The goal is to leave your workplace with everything you came with. Your health, your toes, eyes, ears, nose, everything else that you came with, you want to leave with and have it be in good repair. Carelessness, certainly from my own perspective, my own life, is usually when I get hurt. If I'm being careless or being in a hurry, that's usually when I get hurt. So slow down, think about what you're doing, make sure that you're not doing something stupid. But also keep in mind that unsafe conditions or environment can cause accidents. So you're always on the lookout for those so-called near misses. Sometimes get referred to in industry or here at the university even something almost happened. Well, how can you correct the condition or the environment that caused that almost miss to happen so that it won't happen because the next time or the next person you may not be so lucky. And sometimes stuff just happens. So you want to try to minimize the opportunity for bad things to happen from a safety standpoint. As engineers, you often have two responsibilities. One is your personal safety, but also then helping to create a safe workplace or process or machine as more of a professional in the area. You may be designing a piece of equipment, you may be doing a modification to a piece of equipment, or you may be working with a process. So you have these two roles, and they're both important. Certainly one is more important to your family than the other in terms of keeping you healthy, but the professional obligation to have and help create a self workplace is certainly prevalent. So some generic factory safety guidelines. Hopefully you know all of these, but if not, this will be a quick a review or new material. And certainly the first one these are probably common across many industries, but these come out of more of a production environment or something's being manufactured. And so all employees should wear their personal protective equipment or PPE. So this typically is pretty standard here in the United States, although in other countries, not so much. The idea of safety glasses, you should even be seeing this here at ASU in your labs, although it's a continual battle here for us in the labs to make sure that all the students have safety glasses and wear appropriate clothing and appropriate safety gear. But certainly in industry it becomes a requirement and can be an offense that gets administrative action if you neglect to do these things. You want to be careful about your clothing, jewelry in the workplace or in safety areas or areas where machines are operating. Typically no neckties. I've been on tours or even interview trips, and you go into a plant and people will always be cautioning you about your necktie or even tell you to take it off. That's one example, but often rings, jewelry should be removed in the workplace. Long hair, tied back, out of the way. We had a near miss in our manufacturing lab over in the Sim building when a woman who supposedly had been told multiple times not to have her long hair properly secured, got her hair tied up in a lathe and was getting sucked into it. Fortunately, the lathe was turning relatively slowly, and so somebody could get to the emergency stop switch and saved her. Otherwise, it would have been a very severe accident, probably resulting in death. So we had a near miss, and then I think from then on, people took the idea of keeping your long hair properly secured much more seriously. Tools should be either stored or in use. They shouldn't be left around, shouldn't be left laying on the floor, shouldn't be unsecured, all sorts of things. That's why some of the lean processes in manufacturing are so important, because they help you in that. But more typically they're looked at as an efficiency standpoint, not so much as a safety standpoint. But certainly it's a real issue if you've got a lot of tools laying around. Kept clean and in full working condition. Something that only half works is probably a very dangerous situation. So you need to be aware of those and take the issue of getting things fixed in a timely manner seriously. Instruction manuals, sometimes we forget because we operate machines, or your operators will be operating machines all the time, that somebody else may come along and not know what they're doing. So having a manual relatively handy, or some way they can get appropriate information, a QR code on the machine that links to something is a way to use technology perhaps to enhance safety. But keep in mind that not everybody knows everything about a piece of machine or machinery, and so you may need to provide that to a new user. Should be shut down when things are not in use, power taken off of it, so that the machine isn't sitting there, or the piece of equipment isn't sitting there ready to do harm to somebody without there being realized it's even on. So if a two-handed operation is required, for instance in presses or other sorts of machinery, they should have this two-handed, and that shouldn't be short-circuited or jimmied somehow, to make sure that the people always are operating in a safe way. And you should not remove any safety guards. Many of us, I'm probably guilty of it too, in my home shop, may take a guard off of a saw, for instance, or something because it's continually in the way. I assume some safety risk when I do that. But in the workplace, that can be a real issue from a liability standpoint, a legal standpoint, so you want to make sure that your operators or the people running the plant, when you're again in that perhaps supervisory role or as an engineer, can operate the machine with those installed safety guards. Sometimes you may be designing a piece of machinery and have to install guards, and then I'll have a little problem in the homework that kind of points at some of those issues for you. But that can be an issue from the flip side of when you are creating a process or a machine. You may have to think about guards and make sure that they're appropriate guards and that they're going to work and do the right thing, as compared to be something that's so klutzy that it gets removed to be able to operate the machine. And you shouldn't be running a machine you don't know how to do or use. And so we have issues with that in our own lab. Students come in, try and run a piece of manufacturing equipment without really understanding it. But in plants where somebody may be filling in for somebody, for instance, somebody's out sick and production needs to happen, so somebody gets moved to a machine, you may have somebody moving to a machine that they don't fully understand or maybe have not been specifically trained. So be aware of that danger and try and make sure that anytime you put a person on a machine that they actually have been well trained and understand how to operate the machinery. And make sure you got light. It's amazing how much differences light makes in terms of what you can see and not see. There's been studies done on this, and it's amazing the amount of light and light features even on controls that can make a difference. You can imagine we've got a lot of mining in Arizona. So if you end up working in a mining environment, as some of our graduates have in the past, sometimes those work areas can be very ill lit, and then different sorts of task lighting can be very important. Certainly task lighting can be important in a production environment in a building as well. And ventilation, particularly if the processes are creating fumes of any sort. It could be dust, it doesn't have to be gaseous, but it could be dust. All of those need to be considered. And again, keeping clean and organized. The infamous lean process of 5S helps you do some of these things, but a clean workplace tends to be a safer workplace. And of course, anything with drugs and alcohol involved in industry can often lead to immediate termination. And so if operators are impaired when they're operating a machine, you have to be on the outlook for that, on guard for that, and that's why different companies have drug testing regimes in place, because certainly impaired operators or impaired workers can certainly impact safety. This is not an all-inclusive list. There are many other features, and again, depending on the specific industry you may be working in or plant you may be working in, there may be a range of specific safety guidelines. You go into a new workplace, make sure you ask, try to find out what documentation there is, understanding what safe guidelines are, and always being alert. You may know something that somebody else doesn't. The company, the operation may have gotten lax, fallen into bad habits. As a new employee, tactfully you may want to bring those things up to make sure that the workplace is safe. So OSHA, I mentioned OSHA in the summary. Occupational Safety and Health Administration, an agency of the Department of Labor. It was created back in the 1970, I think. President Nixon signed it into existence, 1970, after Congress passed the law. So it's become, in many ways, a dirty word in some ways because people view OSHA as the enemy. But really, its mission is to assure a safe and healthful working conditions for men and women by setting and then enforcing standards. But there also is a training and an outreach education mission as well. I suspect that the joke here is probably similar to the IRS, you know, the old, we're from OSHA and we're here to help, which can be viewed with some skepticism in industry. And usually it's around safe practices. People, they insist on some things that we do not necessarily see as safety related or as onerous because they are so extreme that it's hard to see how they are important in a safe environment. But you got to remember, always think that usually such a law is in place because something happened someplace. Somebody got hurt, and so then they enforce some sort of rule or come up with a process to prevent that from happening again. Same things happened in education. A young woman was killed in a machine tool lab working by herself late at night, one of the premier universities, and since then a number of different universities have taken action because they don't want to see another student get hurt. So the same thing can happen. It's just like labor laws or anything else. Something bad happens, so often regulation results. So you can see the website there for more information, and again, some of my homework will drive you to that website and to explore it. So they have jurisdiction over most private sector employees and their workers. There are exceptions. And also, states can have an OSHA-approved state plan. In other words, OSHA will delegate, if you will, responsibility for these things to the state. They'll provide support, but the state becomes the primary agency enforcing these sorts of health and safety laws. And that's true in Arizona. It's true for 20-some different states. We have a state-approved plan, and that then becomes the primary program for workers in Arizona. And now keep in mind that that means we have at least as effective rules and regulations as OSHA has, but we can augment those. Now in this case, Arizona has basically adopted all of the OSHA rules and regulations, but then have augmented those. So it's very similar to OSHA, it's just run by the state. So they do have, as I mentioned earlier, more than just rules and regulations. They can provide training resources, also some references, various design guidelines for safety-related situations. And a lot of times this could be a resource to you as an engineer or somebody working in the field professionally. And so make sure that you're aware of these possible resources. And again, some of the homework will have you investigate some of these, just so you're aware. So there are several important issues or policies that are driven by OSHA. Lockout Tagout. Again, this week I was talking to some people, well, what's the most important thing to tell my students about safety? Several of them mentioned Lockout Tagout. If you've not heard of this phrase before, then this will be just an introduction to that. But it is an important process in industry. Certainly I saw it when I was working in a process industry and supervising a maintenance operation. We always had to worry about lockout tagout. So it still continues to be very important in any sort of process industry. And then material safety and data sheets, or MSDS, and right to know. Another important one that you will see all the time in industry. And so you should have some basis of knowledge in that if you don't already. So lockout tagout. More commonly, this control of hazardous energy, where hazardous energy is all sorts of things. Any sort of energy source can be electrical, mechanical, hydraulic, pneumatic, chemical, thermal, anything else, any sort of energy. So there has to be a control process, or this lockout tagout standard, and you can see the standard there on the screen, which is for general industry. Keep in mind that, again, the wide range of processes are possible, or situations, and so there are different areas. For instance, marine safety is controlled by a different regulation, different group even than OSHA. And so depending on where you end up working, there may be things or different agencies or regulation standards applicable to that industry beyond OSHA. But for most general industry, OSHA is it. So again, you need to think about that from your dual role of personal safety. You may need to practice lockout tagout procedures just to keep yourself safe at home, but certainly at work. If you're involved in any sort of machinery or process, you need to probably have your own lockout tagout devices, and there are specific devices. I looked for mine, couldn't find it this morning. I was going to show it to you. One of the simpler ones. Basically, they're often a way to lock out a machine via a padlock that you control, so that once you lock out that machine, nobody can turn it back on until you unlock the machine. And there are various devices to do that in addition to, of course, some sort of lock. But you may want to exercise that at home and at work. And you may end up writing procedures about lockout, tagout, particularly if you're bringing in a new process or new machine into your workplace, whether you've designed it or you're buying it from another supplier, and will have to create processes for your company or for your workplace. Certainly if you're running a small business, if you leave here and start a small business where you got some employees, you certainly will need to think about all of these things, because now you're not only a worker there, but you're also the owner, and will have a different set of liabilities as a result. So material safety data sheets, you've probably seen these here in our labs. Certainly over in the sim building labs, there are binders of these material safety data sheets, and you may have seen them in other venues. There are certainly product safety data sheets, PSDS, or safety data sheets, SDS. They're all basically the same sort of thing. The most common reference, though, is usually material safety data sheets, or MSDS. Note that these are intended to provide both workers and emergency personnel with procedures for how to work with that or to deal with that substance in a safe manner. So it can be physical data, things like melting point, boiling point, or perhaps more importantly, flash point, toxicity, first aid, any sort of reactivity, storage or disposal, protective equipment necessary to work with it, or spill handling procedures if it's a liquid or something like that. So that, again, you can see the differences between working with something and dealing with it in an emergency situation. And so these material safety data sheets have a plethora of things about them, and they can vary. Sometimes different countries have different formats. So where you source the product from, the material safety data sheet may look somewhat differently. The safety data sheets, safe use and potential hazards, and typically it's those sheets, the SDSs, are for a substance not typically used by a general consumer, and so they're a little more occupational focused. But in the normal workplace, you've got all sorts of products, some of which are from the consumer world, so to speak, and some of which are going to be from a specialized kind of industrial setting. You've probably seen these sorts of tags, and I know this is too small on the screen for you to read, but there is certainly important information that's captured on this graphic on the right side of the screen that has to do with a variety of things, the type of hazard, any sort of reactivity, and the general health hazards to them. And you can see that the format on the left-hand side of the screen that OSHA recommends for these material safety data sheets have a variety of components. I'm not going to go into all of those, but they're similar to what we've seen before. So you can see the breadth of information. At different times, different things are going to be important to you, and so you will be scanning these to find out the piece of information you need at that moment. You can see often for a single substance there are multiple pages. So in fact this is 3 of 4 pages for a specific substance. Let's see if I can see what it is. It's a cleaning solvent. So in theory you've got all of these substances, all of these material safety data sheets. So how do you keep track of them? Well, that's why we got right to know stations. And so these are required in a lot of settings. I don't know that we have any of these formally in our labs around here, although we've got something that looks like these in many cases. Photograph on your right is one I took in a lab, not at our school, but at a different school. And you can go online, you can look in some of the catalogs, safety products catalogs, and they will sell you a right to work station that will hold all this information. So the idea is that you have this in one spot, so when people want to know something or an emergency response, they can go right to that space, get everything they need, find what they need to know relatively quickly, rather than having to figure out where it might be. I looked up something, and in Arizona, the most common standard cited for violations, most recent statistics available, which actually aren't that current, but 2 or 3 years ago, was hazard communication, or known as the right to know law. So there were the most citations around this area within Arizona's inspections. So clearly, inspectors think it's important because they view it as important to safety in the workplace. So if you're operating in a plant or working in your own small business, then make sure you take care of this little issue. It's relatively easy. Once you get it organized, it's pretty straightforward. And again, there are products out there in the marketplace that can help you get set up, get organized. So all you got to do is file the information for the products and that you're using in your particular operation. There is a switching now a little bit from kind of the workplace operations side. I want to talk a little bit about safety from a design viewpoint. And so the first issue is, because some of you may be working in the electronics industry, and again, since I haven't met you, I haven't had a chance to kind of know what your backgrounds are, where you may be focused on, and either in terms of your current work or future work. But electrical and electronics equipment, there was a directive adopted by the European Union back in 2003, just updated in 2011, for restriction of hazardous substances. Even though this was adopted by the European Union, it impacts manufacturing in many ways because products move back and forth. And so often, just like in the United States, when something happens in California, it can tend to impact the rest of the United States. Something happens in Europe, it impacts the United States. So the idea is that this is focused on hazardous materials in the manufacture of electrical or electronic equipment. And so this is old enough now that probably for all of us, or for you, assuming that you're not as old as I am, that this is not anything that hasn't been in force since you got in the workplace or will be going into the workplace. So people are kind of getting used to it. It was focused on, sometimes, as you can see, the lead-free directive. So it really impacted electronics manufacturing here in the Valley, because they had to get rid of all the lead in their processes. When I was young, lead was not known to be as hazardous as we now know it to be, and so it was involved in a lot more processes. This process, process guideline of getting rid of this, not just as lead, but also these 5 substances, mercury, cadmium, chromium, and those other two sets of chemicals, which I won't try to pronounce. But these are all impacting now across different industries. And so, for instance, the aircraft industry, cadmium used to be used a lot. Chromium is impacting those. You can see, of course, asbestos was probably the lead one. We got rid of that some years ago. But you can see different aspects of industry being impacted by these things. And again, those are examples of manufacturing and design aspects of safety. The next topic, and one that we'll spend the rest of our time on, is basically hazard analysis. Again, this is just touching it a little bit, but I wanted you to get some sense of this idea of hazard analysis, because it's a little broader and a little beyond what often gets thought about in terms of safety when we talk about personal safety or safety in the workplace. So some definitions. So a hazard is a condition with the potential to cause an accident. So it doesn't mean that it will, but it has that potential. And so we're trying to essentially reduce the danger or the exposure to the hazard. So danger is exposure to the hazard. So first we have a hazard, something that could cause an accident, and danger is then the exposure to that hazard. And so then we have to estimate the damage or consequence that could result from an accident and the likelihood that that damage, again, that the risk will occur. So we need to develop, design, or work to control hazards, those conditions that could cause an accident, and then minimize the damage and decrease the level of danger. In other words, decrease the danger. Keep in mind that's decrease the exposure to that hazard, and that hazard is that potential to cause an accident. So we're trying to control things to minimize danger and risk. So what are typical hazards? Now if we're in class, this would be an interactive spot where I'd be asking you these things. But again, this is going to depend a little bit on the industry you work in. But certainly in some industries, entrapment is a hazard, or ejection. Contact, just touching something, coming in contact with something could be a hazard. Entanglement, I mentioned ties earlier, would be an entanglement. If you're working in some situations, entrapment, something could shift and trap you. Certainly in some process industries that's important. In the upper Midwest, you often hear about people being killed in grain elevators because basically they get buried in grain and suffocate. Impact, something hits you or you hit something. Noise and vibration can be a hazard. And certainly any sort of environmental, chemical, or biological hazards. And again, these are the potential to cause an accident. So general methodology for dealing with hazards, and again, this is kind of thinking about it from a design perspective. You should review standards. There are many standards. ANSI, ASTM, SAE, ASME, various government standards. Those would be the OSHA standards I mentioned earlier and others. So you've got all of these standards. And one of the things I think education fails to do is educate engineers enough in standards. And so when you get into industry, you will find that most industry is governed by some sort of, or some set of standards. They come from different places. Sometimes they're from NGOs, a non-government agency like ASME, something like that, or SAE, but sometimes they could be from a government agency. So you need to be very aware of what standards are applying to your specific situation. And you want to identify any known hazards. This is a tough one. You want to identify hazards. Sometimes they are unknown, and responses using tools like a HAZOP, a HAZAN, or fault tree analysis. And then determine the characteristics of the hazard, and then of course work to mitigate it. So some definitions again, this HAZOP, it's a hazard and operability study. So it primarily focuses on hazards in design or operation, operability. So think process industry. So often you're focused on various situations, what might happen to go wrong, that hazard, and then what the effects of that might be and how to mitigate it. So a HAZOP tends to be team-based study of those hazards and what you can do to fix it, fix the condition, so to speak, mitigate it. And usually it's qualitative in nature. Qualitative means, again, it may not be numbers driven. HAZAN, a hazards analysis, and the word analysis is kind of a key here because basically this is quantitative in nature. So you're going to use some sort of probabilistic analysis to figure out how severe this or how important this specific hazard is. So quantitative versus qualitative, two different techniques for two different sorts of situations. And then the fault tree analysis, which came out of Bell Labs and NASA, both use these. And so it's a little bit similar to a HAZOP. You think about something that might happen and then figure out what would cause that to happen. So it's a little bit of almost like war planning or game planning where you think, okay, here's a condition, what might cause that to happen? So you always want to think about failure modes and then the effect. So you think about not just components, but all the way up to the system. So a specific component might fail. What is that going to do to the system? And that's typically what you may think about in the HAZOP as well. where an operability or an operation or a process operation may be impacted by a valve or some component failing. Think nuclear plants, for instance, where one piece of the overall process goes down. It could cause then a cascading effect of problems that lead to a very unsafe situation. And again, the old saying is, the want of a nail, the horseshoe failed. For want of the horseshoe, the horse failed, etc. And there are various techniques to deal with that as well. So kind of keep in mind the overall view. Again, that first step of reviewing standards is very important and will vary depending on the industry. Lots of standards, they will be important to you. Known hazards, unknown hazards, using things like the HAZOP, HAZAN, again, that kind of brainstorming, what might happen and then what sort of conditions lead to that, characteristics of those hazards, and then you work to eliminate or minimize the hazard. So that's kind of the lecture. Your homework is web-based. There'll be a separate sheet, most of which will take you to the web. Things are a lot easier now than they were in the old days because you can look up stuff and use Google and all that sort of thing. So some of these are just to raise awareness. And if you're not aware of some of these resources or where things are found, so this is not rocket science in the sense of causing you to do a lot of original thinking. But hopefully they'll at least expose you to some of the different aspects of safety and where information, regulation can be found and used in the workplace. So thanks. I look forward to actually meeting you in person next week, which I think will be September 18th. So I look forward to that and hope you have a good week. And thank you.